Hello all, good evening and welcome to the session.
Good
We will
evening, sir.
begin in 2 to 3 minutes. Let others also join. Okay. Is my screen visible? I don't think so, right? So,
No, sir, not visible. Sir, in my weekly activity 3,
Mhm.
I submitted it and I by mistake of giving the like the my Google site link, I have given the link of the spreadsheet where I have done the activity. And sir,
Hmm.
like now in my dashboard in weekly activity 3, it is showing absent. Sir, what should I do?
You should write a mail to support.
Sir, I should write a mail or should I post it in the IITM DSA?
No, discourse, you can post it in the discourse also, but it's good if you write a mail to support, you will get a reply.
Okay, sir.
Are you sure
Got
that you
it.
have submitted it?
Yeah, sir. I have submitted the spreadsheet link, the where I have done the activity, but I was supposed to submit the Google site link, but by mistake I submitted the spreadsheet.
Okay. Is someone reviewed it or?
Yes, sir. Reviewed it. People have reviewed it, but they don't review it completely. I think they are giving good, but giving 50 or 80 out of 100. They don't review it correctly. Someone is
Okay.
giving 100 out of 100.
Then do one thing. Raise it in discourse itself.
Okay, sir. Got it.
Okay. And tag Swati, instructor Swati and Prerna to it.
Okay, sir. Got it.
Yeah, they will take care. Um, okay, so just give me a minute. Um,
Sir, now my dashboard is updated. Now the marks is showing. I just saw now.
okay. Then it's okay, no?
Yeah, sir.
Hmm. All right. So I will try to share my screen. Okay. Anyway, today we are going to do a doubt clearing session on week 11 and 12, where lot of distributions are there, right? Discrete distribution as well as continuous distribution. So it's like almost we are end of the course. It's good to know or understand these distributions little better. Okay, so if you have any doubts related to that, you can raise your hand. I will call out your name and we can have a discussion. The doubts can be from anywhere except from the graded assignments. Okay, so even if you ask from graded assignments, I can give you some hints, but not completely. Right, so okay, so I'm trying to mirror my screen and I'll see whether this will work or not.
Sir, are the concepts of diameter in our syllabus?
What is diameter?
Oh, no, no, sorry, sir. This is statistics class. By mistake, I am asking mathematics one.
Okay. Is my screen visible?
Yes, sir. Yes, sir.
Yes, the sorry, blank white screen.
Yes, sir. Blank screen is visible.
Okay, great. So I can't see. So okay, maybe you guys can see, right? So let me write. So this,
Yeah, but nothing is written.
yeah, I will write. So this will do week 11 and together. Okay, and this is the doubt clearing session. All right. So yeah, the floor is open. If you have any doubts related to week 11 and 12, just raise your hand. I'll call out your name. Any doubts? Okay, so tell me this, are the contents easy in week 11 and 12?
Yes, sir.
Is it understandable easily? So you guys understood what binomial distribution is from Bernoulli distributions, right?
Yes, sir.
Good. And great. Any doubts in activity or practice? These 2 weeks are important, you know. It doesn't contribute to your GAS scores, but in the end term, there will be a significant amount of questions coming from week 11 and 12. Okay, so you should prepare this 2 weeks also.
Sir, will the Z table be given in the intern
Yes,
paper?
yes, yes. So if at all a question asked from asked that involves Z values, we'll give some 4 or 5 Z values. Among them, you have to choose which one is important to you. Okay.
So in the end term, there will be more weightage from week 8
Yes,
to
sir.
week 12, no?
Week 9 to 12 and 9 and 10 might carry 30%. 11 and 12 will also carry equal amount, like 30 to 35%. So it's like overall 100%. You will see some 70% coming from week 9 to 10, week 9 to 12. And the rest 30% will be from weeks 1 to 8.
Sir, can you please guide us through, like, for the week one content, week two content? It is basically that finding out those, like, there is no such numericals involved.
Yes, yes.
So should we focus?
No, no. I think by now we have reached the very end. I think you can expect one question and that too very straightforward question. So you don't have to sit and go through all the scales of measurements or different types of plottings, everything. So you don't have to go through each and everything. The questions that comes from week 1 to 8 will be fairly straightforward. So there will not be any trickiness involved. You would have done that without any concepts at all during week 1 to 8. As well as even now also it will be like if at all a question comes from permutation and combination. So there will not be any too much of trickiness involved, too many cases to be considered or anything like that. It will be a straightforward, simple cases. You can compute it easily. Okay. So spend some
Okay,
time
sir.
on week 1 to 8, but not like you don't sit on week 1 to 8 solving each and every lecture again, learning each and every lecture. Okay. So these things we will do in the revision sessions anyway. So revision sessions, I think they are coming, right? So in that we will clear everything.
Okay, sir.
Okay. So which topic to be focused and which topic can be left out. So we'll do that in the revision sessions. And in week 11, I think we will start with summary is also done, right? So week 11, this binomial distribution and how this binomial distribution is just the sum of Bernoulli's, right? Understanding binomial distribution, it will be like a bell curve, right? So that is there. And how do we practically use this Bernoulli distribution, binomial distributions? And expectation and variance is a very good practice. So whenever you see a distribution, try to compute expectation and variance. That will give you more hands-on practice on different distributions. And when you compute this expectation and variance, no, as you all know, expectation is basically the mean, right? The center of the data. Variance is basically gives you how is the spread and all, right? So when you have these two values for any distribution, you will get a sense of how the distribution is behaving. And if you just have the sense, if you are running short of time in the exam, during the exam, if you have to guess some probabilities for certain events from a distribution, you can guess it better compared to others. Okay, so yeah, Shaili.
Sir, actually, I have a doubt from activity question 11.6, question number 5.
Okay, yeah. So this hypergeometric distribution is a slightly trickier distribution, but not too tricky, I think. Question number 5, is it?
Yes, sir.
Suppose, oh, just a second. My screen got. Suppose we draw 8 cards from a pack of 52 cards without replacement, then what is the probability of getting less than 3 spades? Right? And since it is related to hypergeometric, you should guess that it involves the hypergeometric distribution. Right, so let me write that. Let us discuss this hypergeometric, and I think it requires a proper explanation. So we are going to do AQ 11.6 question 5, which requires distribution, right? So in hypergeometric distribution, what all parameters will be there? So every distribution has some parameters, right? So can anybody tell me?
Sir, N comma P.
Only two?
No, sir. I think it's
It's not binomial, it's hypergeometric.
Capital
M.
MP.
Sir,
Capital?
population,
Yes.
sample, and probability of a one type of and we have to calculate the second type by subtracting the first type of product from the total number of population.
Something like you think of like this. So you have a total population. Okay, so remember this image, and this total population is divided into two parts. One part you call it as labeled. Labeled in the sense you can think of like two classes there. Okay, so one is red class and another one is some blue class. Okay, so this can be yes, no, labeled, not labeled, success, failure, or defective, not defective. So it can be anything. Okay, so there are in the total population there are two classes. Some samples will be in this class and some will be in this class. Okay, so now if I randomly choose a sample out of this, right, so that sample can contain some from red and some from blue, right? So this is a random sampling, right? This sample can contain some people or some items from red and some items from blue. So then the question will be, out of this sample, how many are from red or how many are from blue? So that will create this hypergeometric distribution kind. Okay, so for that, the parameters are n, which is the total population or the population size. Right, so capital R, which is just the sum of red and blue. And there is another variable which is called k, right? Another parameter. And this k is basically, if you are interested in red, you will say k is number of items in red, or we'll say we'll take little better terminology, which is number of items that are success. Okay. And there is one more parameter where we are drawing the sample, right? So this n is the sample number of items drawn, right? And finally, the random variable or the distribution that we are looking at is this x, which is number of success items, we can call it as number of success items drawn. Number of success items in the sample, or drawn is okay, right? This is understandable, right? So it's this capital X is basically this one, this 4, this, it is looking at this, and n is this, and k is this red part, the number of items that are there in the red, and capital N is this whole. Okay, if you sort of understand this picture, then hypergeometric will be very, very easy. Any doubts in this? So these are the parameters we have.
No, sir.
No, right? Is this clear?
Yes, sir.
So okay, so these are the parameters. Now we are interested in uh, finding the probability of different values that this capital X can take, right? So this n is given to us, this k is given to us, this small n is also given to us. The only thing that is not given to us is this x, and this is the unknown, or this is the random variable. This x takes different values, right? And we will be interested in computing the probability mass function for this random variable x. What is the PMF of x? It is probability that capital X takes a value small, right? And capital X is basically the number of success items drawn. The total number of items drawn itself is n, small n. So capital X cannot go more than small n, right? So the number of items that are drawn itself is small n. So there is a bound on our capital X. So this capital X is now number of items. So definitely it is greater than or equals to 0. and this capital X is less than or equals to small n, right? Now this capital X being small x, what does it mean? It means that out of small n items drawn, what is the probability that small x of them are success and n minus small x of them are failures, right? So this is basically probability that x items are success and small n minus x items are failure, or success failure. If you are getting confused, it is like red and blue, right?
Yes.
So now we have to find this probability. So among from the whole capital N, we are drawing n samples, right? So small n samples. So therefore, total number of ways choosing small n items from the population capital N will be n choose small n,
Yes.
right? So this is probability we are computing. So that means we have to compute number of ways x items are success and n minus x items are failure divided by total number of ways n items are chosen from capital N. And number of ways x items are success and n minus x items are failure chosen from capital, right? So this is the probability. And just now we have discussed about the denominator. So the denominator will simply be n choose n. And the numerator, what will be the numerator? So number of ways. So out of small n items that are chosen, x items comes from red and n minus x comes from blue, or x items coming from success, n minus x items coming from failure. So the total number of successes in this particular total population is k. So out of this k, I want x items to be chosen. So how many ways I can choose x items from that k items, right? So that will be
K
k
choose it.
choose x. And not only this, and parallelly I have to choose n minus x. So it's like both events occurring together. So from the failures, I have to choose n minus x items. So how many failures are there? If this is k,
And
this is capital N minus k. So out of capital N minus k failures, I have to choose n minus x failures. So how many ways I can choose that? I can choose that in n minus k n minus x. So this will be the probability mass function of an hypergeometric distribution. Now coming to our question. In our question, all we have to do is to identify what is capital N, what is this k, what is small n, and then we can, what is this small x they are asking, right? So that's all we have to do. So the question is, we have drawn 8 cards from a pack of 52 cards, right? And then what is the probability? So they are asking, question is probability of getting less than 3 spade cards. Okay. So this 3 is a 3 spade card. And for that, we should again draw a picture. So let's say this is the total 52 cards that we have. Right? Among them, we have to choose which are spades and which are not spades. Right? So out of total 52, how many will be spades? How many spades will be there? 13. So that 13 is our success. So if we choose from these 13 cards, then it's like a success for us. And if it is not the spade, anything else is a not spade. Right? So that will be like a failure for us. Okay, so right, so this is a failure for them. And there are 13 cards here. And there will be 39 cards which are failure cards. Okay. So from here, what did we get? So this 52 is capital N. This 13 is K. Right. And small n is 8, which is the samples that we drawn, which is 8 here. And what is x? X is small x is basically, if we want probability that x less than 3, what does it mean? Probability that x can be 0, no spade is chosen, plus probability that x can be 1, plus probability that x can be 2. Correct?
Yes, sir.
So here small x is 0, here small x is 1, here small x is 2. So we can compute each of the probabilities separately. Right? So not choosing spade at all out of 8 cards drawn. So choosing 8 cards will be 52C8 in the denominator. And here out of 13, no card is chosen. And from the rest of 39 cards, 8 cards are chosen. Plus 1 card you choose from the spades. And the rest 7 cards you choose from the other 3 shapes. And divided by 52, choose 8. And for the last probability, it is like you are choosing 2 cards from the spades and the rest 6 cards from the not spades divided by 52 choosing. Right? So if you compute these values, you will get to the answer. Okay, so you can use calculator. I think you'll get some big expressions. You have to cancel it out and finally you'll get the answer.
Yes, sir. I got the
Okay.
basic idea. Yeah, I
Yeah, you
can.
got it. No, you can compute from
Yeah.
here.
Thank you.
Thanks. Okay.
Sir,
Hmm.
sir, like these calculations are very big. Like, is there any way to handle these? Like, even with calculator, it is going to be really big.
We understand, but we do also understand that you have access to all calculators and everything now. So that is why the problems in activity and graded or practice involves more calculations. Whereas if you come to quizzes and term, the calculations will not be this hard.
Okay.
Okay, so the numbers will be slightly lesser.
But like, there is no, as such, no other trick. We have to use the long base calculations only.
Yeah, right. Or
Okay.
if you know the CDF of this particular distribution, I think cumulative distribution function is also discussed, right? If I'm
Yes.
not correct. So if you know this is just the CDF value at x is equals to 3, right? X is equals to 2, sorry. So it is like this is basically probability that x less than or equals to 2, which is like capital F x 2, where capital Fx is the CDF. So if you can compute the CDF of this hypergeometric distribution, then in that you just substitute 2.
But still, sir, you have to calculate the
Calculate
probability.
CDF. Yeah.
Okay.
Yeah. So mm, the bottom line is there is no escape.
Sir, actually, I have one more doubt.
Hmm.
Activity 11.8, fifth question.
All right. So question number, sorry.
Fifth one.
Oh, this is about Poisson's distribution.
Yes, sir.
All right. Yes. Okay, so the number of persons arriving per hour in an insurance company for the insurance of their cars follow the Poisson distribution with parameter 6. Okay, find the probability that exactly 7 people will arrive during any 90-minute period. So the parameter value is changing here, right?
Yes, sir. So for 1 hour it is 6, I think.
For 1 hour it is 6,
And then
but
we
we are
calculate it for 90 minutes.
for 90 minutes. What will be the value for 90 minutes?
6 into
1.5.
yeah.
It will be 9. So the
Okay.
lambda value will
Just-
become 9,
Okay.
right? And we know the PMF of Poisson's distribution, right?
Yes, sir.
X is equals to small x will be lambda power x into e power minus lambda divided by x factorial. Correct? That's it. So all you have to do is find this lambda updated, which is 6 into 1.5, which will be 9. And this x is given, right? 7 people exactly. So small x will be 7.
Sir,
So
actually, this finding the new value of lambda is quite confusing sometimes.
why
Like
is
here,
that?
sorry.
Okay. Yeah. Why is that?
Sir, like sometimes like we are given like lambda for 3 hours and then we have to find lambda for like 1 hour and
Hmm.
like that. So
Oh, you use this rule, no? The very standard rule that we all know. So
the
there will
cross.
be given lambda 1. Yeah, the cross multiplication. Lambda 1 for some k units. So units is like hours or whatever you can measure. If they're asking for k2 units, then the corresponding lambda will be lambda star into lambda 1 into k2 divided by k1, no? right?
Yes. Yes.
That's it.
How to?
So if you use this, I don't think that is too confusing. So if it is 9 for 3 hours, then it will be 3 for 1 hour. It's like that. Okay.
Yes, sir.
Hmm. Okay. Yeah. Any other doubts? No doubts, huh? Everybody is happy with what you have understood from the week.
Sir, actually, I haven't done week 12 till now. I am with week 11 grade assignment. That's why I can't ask doubts from week 12. That's the
Okay.
problem.
So week 11 is okay, right? Week 11 is okay, then week 12 is all about continuous distributions. And that too very basic distributions which are really easy. In my opinion, if you can understand discrete very well, continuousness is just the extension of discrete. Right?
Yes,
So
sir. Yesterday, Swati ma'am taught us the week 12 content also.
then it's good. It's nice to see these
Sir,
random variables and all distributions, graphs. Yeah, Asif.
sir, I've understood the meaning of all these expectation, variance, and standard deviation. So
Hmm.
can you explain in a simple language, not mathematical language, what does it represents?
Which one?
So these expectations and variance and standard deviation means what are they trying to do with these values?
Yes, I just said it in the initial start of this session, right? So expectation is basically trying to find which is the most logical value that represents the distribution. It's kind of like center value. Or if you are doing an experiment repeatedly, what is the most likely value that appears a lot?
So sir, when we talking about like pulling a ball from a bag, so when we pull one ball, that is probability. But when we end all this experiment and at the end of this experiment, what is the value we get? That is expectation.
Average of all the samples that you got is expectation. Average in the sense, so see if you are playing some lucky draw game, okay, so you have 1 to 100 numbered balls uh, in some lot, and you are trying to randomly pick a ball and see the number on it. Okay.
Okay.
So you will not get the same number again and again, right?
Yes.
So sometimes you may get 6, sometimes you may get 99, sometimes you get somewhere around 45. So if you play this game again and again and again and again with repetition, and if you take the average of all the numbers that you have got in every instance, it will come somewhere around 50. That
Okay.
is the expected value. So the expected value is what is the number that you expect
So
logically in some.
so if there is means there's a 10 ball in a bag and 9 ball has number written 1 and 1 ball has number written 10,
Hmm.
then at the end of the experiment the mean value will be closer to 1
1, right?
instead of a middle value like 5 or 6.
Correct. See, because there are 9 1 balls and 1 10 ball, right? So the probability of you choosing one ball is 0.9,
Yes, sir.
right? And the probability that you choose ball 10 will be 0.1.
Yes, sir.
And the expectation is basically value 1 and it has 0.9 probability. And there is also a chance that you may get 10.
Yes.
But what probability? It is 0.1.
0.1.
So the overall will give you the expected value in some sense. So the So if you see, people play gambling, right?
Yes.
So they earn, they lose. There will be a lot of transactions happening in between, right?
Yes.
Eventually, we will lose. That is why it is labeled named as gambling. But people play gambling to win in some sense, right?
Yes.
But if you see something like there is a 50% chance that you may lose 100 rupees and 50% chance that you may win 100 rupees.
Yes.
Uh, so do you play that
Mm,
or not is a question, right? So, or there is a 90% chance that you lose 100 rupees and 10% chance that you may win 150 rupees.
mm,
So what is the expected value, or so what's the chance that we get 150 plus what's the chance that we lose 100 rupees? Is it being positive to us or negative to us? And you have to play carefully, right? So if there are if the ratio is high on losing, nobody plays, right? So this expected value tells us that what is the rough value that I can give to the distribution so that it is exactly at the center, somewhat centered.
okay. Okay.
Okay. And variance is basically how these values are spread, right? So this 1, 1, 1, 1, 1 and 10 is like most of the data points are on 1 and 1 is an outlier which is at 10. So if you compute the variance, because of this, you will get some large variance to this particular data set, right? So it will not be around mean. So mean is somewhere 0.9 plus 0.1, right? So this will be 1.
So it's like we have read in expectation and variance how the outliers behaves in the variance. Like it affects
Mm-hmm.
variance more than the
It
expectation.
affects, correct. It affects variance more because these outliers kind of uh, disturbs the data in some sense. So you have to consider them, and the spread looks like it is distributed across a big region because of that outliers, and therefore the variance will increase.
And so deviation. These two are mostly understandable, but standard deviation, what is
Yeah.
its
So standard
duty?
deviation is used to maintain the units with the data points. So when you compute variance, the units that you will have with variance and the data point, the data. So if you, let's say you are collecting the data of heights of a person, right? So when you compute the variance, so height of a person, individual person, you would have collected with respect to centimeters or meters.
Yes, sir.
But when you compute variance, it will be meter square, right? So
Yes.
meters and meter square, you cannot compare directly, right? So when you take the square root of variance, it will again come back to the meters, same units as the data point. So this standard deviation says within the units itself how the spread is. So that's the advantage of standard deviation. And standard deviation is just square root of variance. That's it. Nothing
Square
more.
root of variance.
Yeah.
So both are just explaining the distribution of a data in a sense.
Correct. Spread of a data. But standard deviation is basically maintains the units also. So it also balances the units. Whereas variance will give us a value and the units will be squared to it.
Okay, so
Sir,
thank you.
I have a
Yeah.
question. So here there is a variance, like we have calculated like variance for 1 and then 10. Suppose if we have instead of that this 1 to 10, like 1, 2, 3 till 10,
Hmm.
then which one has like higher variance?
Then that is what, no, we have to compute, no? So if
Sir,
you
we
compute,
cannot look at the units and say like here the difference between the units is like 1, whereas here it's 9.
difference
Can we
between
like
what?
say between the units like 1 to 2 it's 1, 2 to 3 it's 1,
No,
like
no,
that.
no, no. See the spread, you will see the spread from a fixed point, right? So you'll see, you fix a point and you see from that point how the distribution is spread. So it's basically variance is you are seeing, you compute the expected value. So that is why you see how far each data point is from the expected value. So that's the formula of variance, right? So how does it come? So variance of x is basically again the mean of right. So it's like how far each data point is from away from the mean, and you square it and take the overall mean. So something like this data set will have mean around 5.5,
Yes.
right? So 55 by 10, 5.5. So 5.5 is the mean. From 5.5, 5 is 0.5 units far, 6 is 0.5 units far. So likewise, all other data points will also be some units far from this. And you square them and you take the overall average, and that is variance. So that will give you the spread of the data. And even here also, the mean is at 1. So 9 of your data points are exactly at mean. And only one data point which is very far, which is 9 units far. Right? So the variance will be 1 minus 1, 1 minus 1, 1 minus 1. All 9 points will not have any variance at all. They are exactly at the mean. Only the last data point is 9 units far, and 9 square is 81. Correct?
So, sir, in a way, we are calculating the sum squared error here, right? Is that what a variance is?
Ah, some squared error or residual square error, right? So residual is just the difference between mean and each data point. Ah, so we are doing sum of squared errors, but later we are also dividing it by total number of data points. So it's like mean of some squared error is all.
Okay, okay. Then we take just to get rid of that square unit so the error doesn't really shoot off. That's why we do the standard deviation, right? To get
Hmm.
a normal value.
To get the same value, just to compare, right? So if the
Okay.
standard deviation is 6 units, then you will see that how many data points are within 6 units, how many data points are within 12 units. So like you can actually see the distribution. If it is variance value, you take the variance value. Variance value doesn't tell us anything about the spread, right? So when you draw the plots also, this is how you draw, right? So you might have a distribution like this. You will see one standard deviation far from the mean. Mean can be here, and you will see how much data is one standard deviation far. And then you will also see two standard deviations, three standard deviations. So the data spread is measured with respect to standard deviation, not variance.
Because the units are same here, I see.
Here units are same, so you can do this. With variance, units are not same.
Sir, in the same graph you have drawn,
Hmm.
it is said to be like most of the data lie between these two, the plus minus of standard deviation.
Standard deviation.
So
So
what does mean most of the data here?
most of the data, see if it is normal distribution, it's 95% of the data lies within one standard deviation,
Okay.
right? So like most of the data mean if you have 100 data points, at least this 95 data points will lie within this.
Okay.
Only that is what this sigma tells us. So after computing whatever sigma you get, that sigma tells us that 95%. So you plot this sigma on the number line to
Yes.
the right and left of mean, you will automatically get this 95% of the data within it. And then two standard deviations, I think 97 or 98. And the third standard deviation, it will almost include 99.75.
It can never be one. Means
It
100%.
will never be one, but within three standard deviation, there is a three standard deviation rule or something. So 99.97% of the data lies within three standard deviations. Okay. And from then on, fourth standard deviation, fifth standard deviation, it will never be one, as you said, since these are going till starting from minus infinite to plus infinite, it will never be one. Okay. So similarly, like this, for any other distribution, standard deviation tells us how the spread is, and the value of sigma tells us how far is my data points are. So if the sigma is very large, that implies that my distribution is spread over a big region. If the sigma is small, then most of our data points are very close to mean.
So for in this graph, we can see there is a mean and there is a sigma. But in this graph, because of the difference in the unit, we cannot plot the variance here.
We cannot plot the variance.
Okay, yes.
Okay. And variance is not just sigma square. So you cannot say you plot sigma square and say that is the variance. It doesn't make any sense.
Yes.
Okay. Good. Yeah. Anything else? And you will see a lot of these things coming in stats too. Definitely, we are going to play around graphs, identifying the support, and vertical stripping, horizontal stripping. So it will be fun.
So do we have to use the MATLAB also in the
No, not in statistics 2 course.
Okay.
Definitely not. So we are not going to deal that advanced things. MATLAB and all, we are not going to use MATLAB, but we are
Yes.
going to use R in LSM and statistical computing. Statistical computing, we are going to use R. And even in LSM, which is linear statistical models, these are degree level courses. So there you will study these ANOVA tables and all. So there you have to write or you have to draw samples, you have to generate samples using this R and all. Okay, so R is more handy when it comes to statistics. So all the distributions are one line code. Whereas Python or MATLAB, you have to write at least 2-3 lines to generate a samples from a distribution. Right? And CDF it's like just the CDF of in R. It will plot you the CDF. So for statistics, at least R is more user friendly and easy. So the syntax will be very, very easy in R. So, but we will see all these things in degree level, not in foundation. Okay.
Okay, sir.
All right. Anything else? So go through week 12. Okay.
So
So we have,
we can ask doubt from week 12.
yeah. This is for both week 11 and 12, no?
So I have few doubts.
Okay.
So activity question activity 12.2, question 5 and 9.
12.2. Question 5, which is connected to question 4 in some sense, right?
Yes, sir.
So suppose the time taken by a student to finish. Okay. So given that time taken to finish a quiz is uniformly distributed between 30 and 45. Is this true? How much time will you guys take to finish a quiz? Hmm? Sorry, your voice is too low. For one subject? Okay, all right. Hmm.
45 approx.
Oh, 35. Then it's true then. No, I thought you guys will say more than 1 hour at least.
Yes, sir, around 1 hour at least.
Okay. Okay, fine. Since the question is given like this,
That
let's
depends
assume that student
on
will
the
finish.
calculation.
Sorry.
That depends how lengthy are the questions in the thing.
Mm-hmm. So far, what is your experience?
Yes, sir, 40 to 45 minutes because I spend extra time on checking also.
Okay. Okay, good, great. All right, so let's come back to this problem. So time taken to finish a quiz is uniformly distributed between 30 to 45. So the length, right? So uniform distribution we all know, right? So it will have the same probability density value, which is called PDF, right? Between 30 to 45, and the value is, so the probability okay, I have to be a little careful, the notations and all. So if I'm using very fancy notations, do let me know. So is this PDF, for PDF, is this the notation that is used in the lecture?
Yes, sir.
Fx,
Yes, sir.
correct?
Yes, sir.
Okay. So Fx of small x will be what? So it will be some value between when x is between 30 to 45. So the continuous, we have more liberty, so you can put equal to or you can remove that equal to, it doesn't matter at all. Because probability at a particular value for a continuous distribution is 0. So even if you include or doesn't include, it doesn't matter. And any other value of x, this will be 0. But you should tell me what will be the density value when small x takes value between 30 to 45. Come on, easy. Oh my god.
So 100.
Not 1. Okay.
1
So
by
then that
15.
1 by 15 is correct. So for any PDF, okay, so this is a property of PDF, right? Probability density function. So when you plot that PDF, the area under the curve of PDF should be, area under the curve actually represents the probability, okay?
Like it will be equal to 1.
It will be equals to 1. So when I plot this Fx, since it is uniform, so this density should be the same between 30 to 40. 30 to 45. And we also know anything above 45 or anything below 30 will be 0. Right, so that is also known to us, that also we can plot. So this is anyway 0. This is anyway 0. So it will form a rectangle, that is for sure. But all we should know, all we should compute is what is the height of the rectangle. Right, so it will form a rectangle. It will form a rectangle This is 30 and this is 45. But what we know is the area under this curve, under this PDF, it actually represents the total probability. And we all know the total probability should be 1. Right? So X takes only values between 30 to 45. And this will, from 30 to 45, it will cover all the values of X. So if I add the probabilities of all the values of X that are actually possible, it should give me 1. Right?
Yes, sir. So I was confused with that. But
So
area will be 1.
area will be 1.
Yes, sir.
So if area should be 1, this is a rectangle we know, right? So area is basically length into
Breadth
breadth
or
or height.
height.
So the length is 15.
16. So it should
What
be
should be the breadth such that the product becomes 1?
1 by 15.
1 by 15. And this will be 1 by 15. That's it. Once we have the PDF, now we can compute any event probability. So question 5 says, find the probability that the student needs at least 35 minutes to finish the quiz, given that she has already taken more than 30 minutes. Right, so the question is, so there is a condition given to us, right? So she has already taken 30 minutes. So that is the condition given to us. And what we have to find, given this condition, we have to find she will take at least 35. That means which is greater than or equals to 35. Right, so this is the conditional distribution. So conditional distribution, I can write it as x greater than or equals to 35 and x being greater than 30 divided by, right? Is this discussed? How do you write this? So probability that A given B, 2 events. Probability that A intersection B divided by probability of B.
Yes, sir.
Correct?
Yes.
So here event A is this, event B is this. Right? So comma is like intersection. What is the probability? So x greater than or equals to 35 and x greater than 30 is basically x greater than or equals to 35. Right? So both events should satisfy. So when x is greater than 35, greater than or equals to 35, it is obviously greater than 30. So this will be probability that x greater than or equals to 35 divided by probability that x greater than 30. What is the probability that x is greater than 30? You can see here. What is the probability that x less than 30?
0.
0. So probability that x greater than 30 is basically 1 minus probability that x less than 30.
1.
Which is 1. The denominator becomes 1. And the numerator, what is the probability that x is between 35 to 45? Correct?
Yes, sir.
So probability that x is 35 to 45 is the answer. So what will be this? This is, you can do it in many ways, many ways. So the overall from here to here is probability 1. From here to here, you can compute the area. Right? So this is the thing we have to compute. So this is the probability we want. So the area under this curve from 35 to 45,
So simply we can subtract like 45 minus 35,
which will be
which will
10
be
and
10.
10 and divided by 15. No,
Yes,
10
sir.
is not the
So of
probability.
course 10 divided by 15, but like we can do like that, right?
Yeah, we can do like that. So we'll do like that. 45 minus 35, but even this also, you can write it as probability that
45 minus
30 less than x less than 45.
Yeah.
So you
it's
can write it as
45
45 minus 30. So this will give you 10, 15, 2 by 3. Right? So if you check, I think
Yes, sir. This is it.
this is the correct answer, no? Yeah. And what is the other question that you asked?
So ninth.
Okay. Suppose that the random variable x is uniformly distributed between 0 to 10, 0 and 10. Then find the probability that x plus 10 by x is greater than or equals to 7. Right, so the given is x is uniformly. Is this known to you guys? I think it's a good time to teach you this similar symbol.
Yes, sir.
Okay, then I will write it like this. X is uniform between 0 to 10. Right, and right, so what we can do is, since x is a positive value, I can write this as, I can cross multiply x and multiply x to the right side. Right, so I can do this because x is anyway between 0 and 10, so you can exclude 0 also. So it's a positive value, I can do that. So this is basically probability that x square minus 7x plus 10 being greater than or equals to 0. So probability that I can split this as x minus 5 into x minus 2 greater than or equals to 0. So any value between 2 to 5, you can see that it goes below 0. Correct? Because it is a product of two numbers. Any x that is between 0 to 2, this will be negative. So any x between 0 to 2, you can clearly see this is negative and this will also be negative. Overall product will be positive. When x is between 2 to 5, you can see that this will be negative and this will be positive and the product will become negative. And when x is between 5 to 10, this will be positive and this will be positive. Overall product is positive. Positive is basically greater than or equals to 0. Right? So in these two cases, the inside event is true. And we want the probability of happening these two events. Understood?
Yes, sir.
Is it okay or got
Yes, sir.
confused with
Understood.
how it is? Understood, right? So all you need is, what is the probability that x is between, or you can simply do it in one line. So this will be simply 1 minus what is the probability that x lies between 2 to 5. So that will be 1 minus 5 minus 2 divided by 10.
Yes.
Right, so this will be 1 minus 3 by 10,
7 by 10.
which will be 0.7. 7 by 10, which is 0.7.
Okay, sir.
Okay.
Yes.
Yeah. All right. Good. What else? Okay. So anything else? All right. As I was saying, week 12 and week 11 are really important, and we will do lot more problems or problems that are very close to our end term preparation, so that it will give us some hands-on experience in practicing, as well as it will fetch some marks maybe in the end term. Okay. By then, please be ready. I mean, ready means you should have watched the lectures, you should have gone through the assignments and everything to understand it. Since they are revision sessions, we will not be sitting and doing theory and summarizing concepts or anything. Right? So we'll emphasize what concepts are important and we'll do problems around that concepts. Okay. So come prepared, and that will help you to prepare well for your end term. Okay. All right. Anything else? Okay, great then. Can we close then? Okay. So yeah. Okay, I think one doubt. Okay, I will let Swati ma'am know this. All right, guys. Thanks all for joining, and have a great day. We'll meet in the next revision sessions. Okay, bye.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
Okay.